Hello guys, this is welcome to our class for today. This is Nobel Science Tutors Online, and this is your physics tutorial. And for today we'll be looking at stationary waves, and then we'll also look at stationary wave equations, and then see how we can solve some problems using these progressive wave equations. Okay, so if you have not subscribed, please click on the subscribe button. Also click on the notification bell so that whenever we upload a new video, YouTube will notify you. Also, please continue to do your test your understanding questions so that we improve in your learning. Besides that, please, if you have a friend, you can also invite them to come and enjoy what you are enjoying in YouTube. You can reach us via the WhatsApp number that is showing on your screen. And if you have any challenge, please let us know so that we can put us together and help you. Is that okay? So please get your writing materials, get yourself settled, and then so that we can go straight to the class that we have for today. Alright, so you are welcome to this class. As I said, we'll be looking at stationary waves and different types of stationary waves. Then we'll also look at progressive wave equations and then solve some problems. Is that okay? So welcome to our class, and let's just go straight to what we have for today. So stationary waves. What are stationary waves? Stationary waves occur when two interfering waves of the same amplitude and frequency travels in opposite direction. Okay, just like as you have in this diagram. Okay, so these are two waves. These are waves that are traveling in opposite direction. That's okay, but you see that there's a node here and then there's a node here. All right, so for stationary waves we have two types basically. So we have stationary transverse wave, and then there is also stationary longitudinal wave. So for stationary transverse wave, this type of waves are obtained when a string fixed at one end or at both ends is set into vibration. Okay, so when a string that is fixed at both ends is sent into vibration, you have a stationary wave. So here you have, like here now, this is the incident wave, and then this one is a refracted or reflected wave. Okay, and then the distance between the nodes gives you the wavelength. Okay, distance between this node and this gives you a wavelength. And don't forget that this is a crest, this one is a crest, and this is a trough for this particular wave. Then this is a crest, this is a trough, and then this is a crest for this particular wave. So this is a typical drawing for a stationary transverse wave. Alright, so the other stationary wave that we have is longitudinal wave. Stationary longitudinal wave. Stationary longitudinal waves are set up in open or closed pipes when the air particles in the pipes are set into vibration. So this type of waves, you always actually get them in open pipes, and the example of them is sound waves, right? Example of stationary longitudinal waves are sound waves. Sound waves in either open pipes or closed pipe. So this is the incident wave, and then this is the reflected wave. We will discuss more on this in when we discuss sound waves. Okay, so when we discuss sound wave, we'll talk more on this stationary longitudinal wave, but they are mainly set up in open and closed pipes. Okay, so example of them, as I've said, are sound waves in pipes. Sound waves in pipes. Okay, so this is just what we have for stationary waves. Then we are going to look at some wave diagram and then see how we can solve some problems on the progressive wave. Okay, so let's look at a wave diagram now. So basically, This is typically a diagram for a stationary wave. Okay, so most stationary waves are obtained as a result of the combination or superposition of an incident wave and its reflected wave. Okay, so the reflected and the incident wave, they are of the same frequency and amplitude, but they are traveling at different phase. So the two waves are basically out of phase, right? Because they are traveling opposite to each other. They are traveling opposite to each other. So if you look at this drawing very well, you see that in this particular wave drawing, you have, this point here is called the antinode. While this point of intersection of the two, of the reflected and incident wave, is called the node. Now the distance between the vertical axis of projection and an antinode is equals to 1/4 or 1/4 of a wavelength, while the distance between the vertical axis and the node is half of a wavelength. Okay, so this is what you have, and if you look at this, as I said, you have a node and an antinode. Now the node is the point of is a point on the stationary wave where the two the reflected and the refracted wave, or the reflected wave and the incident wave, where they meet. Okay, while the antinode is a point on the stationary wave where you have a maximum displacement of the medium. That is the antinode. We already know that this point normally is called the amplitude of the wave, and the amplitude of the wave is the point of maximum displacement. So the antinode is the point on a stationary wave where you have maximum displacement of the medium. Okay, so this is a typical diagram of a stationary wave. So now we're going to look at a progressive wave and then a progressive wave equation. Progressive wave equation. Okay, so for a wave that is traveling perpendicular to the direction of vibration, there's a wave equation that relates the y-axis, which is the direction of vibration, to the direction of propagation. Is that okay? So the direction of displacement and then the direction of propagation, they are related by a wave equation that is called the progressive wave equation, and mathematically it is stated this way: that y is equals to a, which is the amplitude sine 2 pi the distance, the s direction, all over wavelength. So this is an equation that has already been derived. So what we just do is to use it to solve some problems. That okay? So y is the vertical displacement of the wave, lambda is the wavelength, a is the amplitude of the wave, which is the maximum displacement of the wave, then x is the horizontal coordinate of the wave. Now this particular equation, 2 pi x all over lambda, is given as the phase difference of the wave. Okay, so this is the phase difference of the wave, then this is the progressive wave equation. So I will encourage you to take note of these two equations. Okay, so take note of these two equations. They are very, very key. We'll use them to solve different problems as we go on. Alright, so we are going to apply these two equations now to solve some problems, so that we see practical application of this equation. And this equation, this progressive wave equation, depending on the direction of travel of the wave, either positive direction or negative direction, you can vary this equation. So mathematically, this equation has been derived in various forms, and these are the forms that I want to show you now. So that simple equation has been derived, and mathematically it can also be stated in various forms. That's what I just said before. So it can be stated as y is equals to a sine 2 pi over lambda. Then you have x minus velocity times time in brackets. Now if the wave travels in the opposite direction, the equation can also be written in this order. It's just to change the order of the s and then the time. Okay, also the equation can also be written this way. Take note that this is angular velocity. An angular velocity from simple harmonic motion is given as 2 pi f. So in some of the equation, you see that we substitute 2 pi f for angular velocity. Or this equation can also be written if the wave is moving in the opposite direction this way. Okay, so these various equations apply depending on the problem that you are given. You can use them to solve different wave equation. Note that frequency is equals to the reciprocal of what? Of the period. Frequency is equals to the reciprocal of period. So you take note of that, because when we'll be solving some problems, you will see how frequency and periods are interchanged. As you are solving the problem, you see where how you interchange the frequency and the period. Okay, so that is what we're going to do, so that you have some mastery of how to use this wave or progressive wave equations to solve problems. So please guys, take note of these equations as I've listed them here. Just take note of them so that you can apply them to solve any problem you have on this. With these questions, you always see them in JAM and all that. Alright, so let's see how we can actually solve some problems using this wave equation. I ask you to take note of this. Angular velocity is equals to 2 pi f. Velocity of a wave is equals to lambda f, and then period is equals to the reciprocal of frequency, or vice versa, as the case may be. So let's go straight and solve some problems. Right? Let's go straight and solve some problems. So this is a sample question. Okay, so with this question now, we want to see how we can apply these equations that we just derived to solve some problems. This question says that a plane progressive wave is represented by the equation y is equal to 0.3 sine 200 pi t minus 20 pi x all over 18. Find the frequency, the wavelength, and the speed of the progressive wave. Okay, so if you look at this question now, what we'll do for you to solve any problem using this progressive wave equation that we just discussed, what you do first of all is to write down the equation. Okay, so first thing that you do is to write down the equation. So once you write down the equation, you will now compare these two equations. You compare the two. From there, you will now start to solve. So let's go straight and let me show you how you do that. Okay, so the progressive wave equation is written as y equals to a sine 2 pi t all over capital T, which is period, minus 2 pi x all over lambda, all in brackets. So when you are given any problem like this is the first thing that you do, right? So write down this equation. Then the next step is that you are going to compare this equation with the equation that you are given. Okay, so if you want to find period or frequency, you do your comparison. So if you look at this question very, you find out that this A that is here, which is the amplitude of the wave, corresponds to 0.3. This sign is this sign that is here. Then this part of this question corresponds with this. Okay, so this corresponds with this. Why this part corresponds with this? So when you want to solve with this equation, what you do is that you take the part by part. You take it part by part. So what you now write is that comparing the two equations, that is what you write. That is the next statement that you write. Comparing the two equations. Okay, so you write that down, that comparing the two equations, you will now have that 2 pi. Now you are comparing these two equations, so you write comparing the two equations, comparing the two equations. All right, so you write comparing this equation and this particular one that you have written. Okay, so when you compare the two, you see that 2 pi t all over t is equals to 200 pi t. Okay, so this is what you will have. Now remember that frequency is equals to 1 over t. Now this 1 over t is here. So this equation, you can write it as 2 pi f t equals to 200 pi t. I hope you remember this. Okay, so having written that, you can now divide both sides of this equation. Divide both sides by pi t, because that is what is common, right? Divide both sides by pi t. You have this will cancel out, and this will cancel out. Then this and this will cancel out. So what you have left is 2f equals to 200. So your f, which is the frequency of the wave, becomes 200 all over 2. So your f is equals to 100 hertz. 100 hertz. Okay, so this is the frequency of this wave. You see how the equation is used. So you just, once you have this simple understanding, the answer comes very readily. So after you have done this part for the frequency, you can now do that part for the wavelength, because this part of the equation now represents the wavelength. You can see their relationship. Okay, so for you to solve for wavelength, you also pick that part. So this is for frequency. Then you say for wavelength, for lambda, you now write that 2 pi x 2 pi x all over lambda is equals to 20 pi x all over 18. Alright, so what you now do is that you can do cross multiplication. Okay, so when you do your cross multiplication, you are going to have 36, okay, pi x equals to 20 pi x lambda. So you can, pi s can actually cancel. If you divide by pi s from the two sides, you have this divided by pi s, this divided by pi s. So this cancel that, and then this also cancels that. So you now have 36 is equals to 20 lambda. Okay, so your lambda, which is your wavelength, is equals to now 36 all over 20. So by the time you work this out, you're gonna, your wavelength is equals to 1.8 centimeters, as the case may be. So this is 1.8 centimeters, that's your wavelength. So you see how the equations are used. Now for you to find the speed, we know that speed equals to what? Lambda f. So just substitute into that equation so that you have 1.8 multiplied by what? 100. Okay, so by the time you work this out, you're going to have that the velocity or the speed is equals to 180 centimeters per seconds. So guys, how do you see this? I think it is relatively simple, right? It is relatively simple. Now assuming we're asked to find the amplitude of the wave is 0.3. That's all. You don't need to do more than that. The amplitude of this wave is 0.3. So it depends on the equation that you are asked to solve. This is just how to use this wave equation to solve any problem basically. There's no magic to it. The equation looks a little bit big or cumbersome, but once you understand it this way, it will be very easy. So right away, let's do another question. Let's solve another one. Okay, so just as you did in the previous one, that is exactly what you're also going to do here. So you are going to write down the progressive wave equation, which is equals to y is equals to a sine 2 pi t all over t brackets minus 2 pi x all over lambda brackets close. Okay, so once you are written this equation, you can actually use them to solve any problem that you have. Alright, so just as we did before, what you now do is to compare the two equations, do the comparison between the two. Alright, so you compare these two equations and then apply the equation the way we did before now. Don't forget, if you look at this equation, you find out that the 2 pi is outside the bracket, so you have to use to multiply what is inside here. Okay, use this 2 pi to multiply what is inside so that the two equations will look exactly the same. So that is just a simple variation between this and the other one. Don't forget that this is amplitude and this is amplitude. So use this 2 pi to multiply whatever is inside, then do your comparison. So right away, comparing these two equations, will have that for you to find the period of the wave, you have that 2 pi, you have that okay, so when you do that comparison, you will have that 2 pi t all over period is equals to 2 pi times 0.15 t. Okay, because I told you that use this 2 pi that is here to multiply what is here so that these two equations can look the same. Okay, so this is what you will have. Now you can do, don't forget that here you are looking for period. Okay, so you can do your your cross multiplication so that you find the period of the wave. Okay, so do your multiplication, then so that this one I will give you 2 pi t is equals to 2 pi multiplied by 0.15 t times capital T. So if you divide the two sides by 2 pi t, divide the two sides by 2 pi t, you are going to have this will cancel out, have 1, then this will cancel this, and then this will cancel this. So you are going to have 1 is equals to 0.15 capital T. So you are looking for period now. So T will be equals to 1 all over 0.15 seconds, or you can divide that out. So when you divide this out, you are going to have that T is equals to 6.8 seconds. Okay, then to find the frequency, you know that frequency is equals to what? Frequency is equals to 1 all over T. So substitute into that 1 all over 6.8. So when you divide this out, frequency will be equals to what? To be equals to 0.15 Hz. 0.15 Hz. I hope you are seeing the way the equation is going gradually. Now, for you to find the wavelength, you still do another comparison. You compare this to this. Okay, you compare this side to this side. Don't forget, multiply the 2 pi. Use it to multiply this part of it. Okay, so for you to find wavelength, you compare that so that you have 2, say for, alright, that for wavelength, you do your compare, you have 2 pi x all over lambda is equals to 2 pi multiplied by 0.1 x. Okay, so if you follow how we'll be solving all these questions before, you will observe that the 2 pi x will cancel out. Okay, so if 2 pi x will cancel out, it means that this will cancel out and then this will cancel out. So you are going to have 1 all over x is equals, so these are giant questions, equals to 0.1. Okay, so your lambda will be equals to 1 all over 0.1. So, and that gives you 10 centimeters. So this is actually a wire question then. So after you've done that, so your lambda is 10 centimeters. Now velocity of the wave is equals to lambda the f. Okay, so you can just substitute, so I have 10, you have 10 multiplied by 0.15. Okay, so when you multiply that, you're going to have 1.5 centimeters per seconds. So that is the velocity or the speed of the wave. So if you look at all this question, you see the way you apply this progressive wave equation to solve your problem. I think this is relatively simple if you are actually following what I'm doing. Okay, so I will solve just one more problem, because I believe that with what I've done so far, you should be able to solve any problem on this. So I'm just going to take only one more question or one more problems from this. Okay. so this one, there's no time to waste here. It is just the same thing what we'll be discussing before. So what you do here, just write the equation down. Y is equals to a sine 2 pi t all over t minus 2 pi x all over lambda all bracket. Now comparing these two, we are asked to find a frequency. Okay, we are asked to find frequency. So if you compare these two, we have that 2 pi t all over t is equals to 2000 pi t. Okay, it's equals to 2000 pi t. So don't forget that f frequency is equals to 1 all over t. So this equation can also be written as 2 pi t f is equals to 2000 pi t. Now divide the equation by pi t, you have this. So when you divide it, you are going to have this. This will cancel out, this will cancel out. So you have 2f is equals to 2000 to 2000. So your f will be equals to 2000 divided by 2. And when you work that out, you are going to have 1000 hertz. Okay, so I think this is relatively simple. So guys, thank you so much for listening, and this is where we are stopping our class for today. But before I go, this is your test page. Okay guys, please just try and handle these questions. They are simple and easy. Just follow the steps that we've taken, and then you'll get your answers readily. Check your textbooks, right? Check your textbooks. Check some past questions in WAEC or even in JAM. You will see questions like this. Try your hands on them and see how you have been able to comprehend this particular aspect of wave or progressive wave equation. Okay, so thanks so much for your time. And before I leave you, please, if you have not subscribed to our channel, what are you waiting for? If you like what we are doing, subscribe to the channel, click on the notification bell so that whenever we upload a new video, YouTube will notify you. You can give us a call via the WhatsApp number that is showing right on your screen. Right, so this is Nobleman Science Tutors Online. I remain your YouTube tutor, and my name is Otobo Michael. You are welcome, and please have a nice time. Invite your friend to come and join this channel, and tell them to subscribe. Give us a thumbs up, give us a like if you like what we are doing, so that we can continue to encourage us. So thank you. We'll see you in our next video. Thanks.